Hello everyone, my name is Fayssal El Kotob and I'm the head of the solutions department at Jubaili Brothers UAE. I hope you are all doing well and staying healthy and safe. Thank you so much for joining us in this webinar. Today we have a special guest speaker, Mr. Bedig Boghossian, who is the technical support engineer from DSE Electronics. I've known Bedig for a while, and when it comes to genset controllers and technical related issues, Bedig is an expert. He has an outstanding knowledge in this field, and I'm really honored to have him as my co-host in today's presentation. So, as usual, we've covered engines and alternators in previous webinars. So today we'll be covering generator controllers. And as usual, we'll start with a generic question, defining a generator controller. We'll also answer the question, what is CAN? Because CAN links are very common in generator sets and generator set controllers. We'll also have a very quick overview on genset electrical protections. From that point forward, we'll move into DSE WebNet. So we'll see the various DSE WebNet gateways. We'll have a general overview on DSE WebNet, and we will discuss the key features of DSE WebNet. Now, this part here is going to be the area of focus in my part of the presentation. Following that, we'll discuss the Jubaili Brothers and the DSE Electronics business relationship or correlation. From that point forward, I will pass the microphone to Mr. Bedig, so he will give us an insight and more details related to DSE products and their services. By the way, before I forget, as I go through the slides and Bedig does his part of the presentation, if you have any question on the chat box on the right-hand side, there's a question mark icon. Please click on that and type in your question so we can address all questions by the end of this webinar. So what is a generator controller? A generator controller is a device used to monitor, start, and stop a generator. So basically, it's a device used to monitor and control a genset. Just like any other machine, a generator set has various parameters that must be monitored and checked during normal operation. So basically, in a nutshell, a genset controller is a human-machine interface. It connects us with our generator, okay? So we can give our genset certain commands and read its feedback or read its parameters. So some of the items that are monitored through a genset controller are oil pressure, engine temperature, fuel level, engine temperature, and coolant level, for example, and several others. So the most common link between a genset controller and the engine is a CAN link. CAN stands for Controller Area Network. It's a short-range communication link. It's designed to pass information very quickly and securely between the CAN, ECU, and the generator controller. It's really quick. The speed of data transfer could reach 8 megabits per second over CAN. And it helps us to communicate with the engine ECU. ECU stands for Engine Control Unit, or in some other cases, you'll see it written as ECM, which stands for Engine Control Module. So the system passes all the information on engine parameters like oil pressure, temperature, fuel consumption, engine speed, and much, much, much more. Okay, so the ECM reads hundreds of parameters. Okay, but what we see on the controller are the only ones we are interested to read. So many ECUs also support the starting and engine control and stopping of the engine by messages sent by the generator controller over the CAN link. So it's not just about retrieving data or reading data. It's also about sending commands, start, stop, and other control commands. DSE controllers support a wide range of CAN ECUs. For us, Jubaili brothers, typically we are only interested in Perkins ECUs because we deal with Perkins. We are the only self-service OEM of Perkins engines. However, we might utilize other engines only if the customer requirement demands another brand. Okay, but basically, we are concerned only with Perkins ECUs. So when it comes to controllers, many of you know there are different types of controllers. Normally, our excuse me, our standard controller is a DSE6110, which is a text-based controller. Now, for electronic engines, it is recommended to use a text-based controller for the CAN message displays. CAN messages or alarms sent from the ECU are decoded to be displayed on the text-based controllers, which can be easily interpreted, whereas icon-based controllers are limited in displaying text messages. Just so you get an idea what are icon-based controllers, there's no text display. Think about the dashboard in your car. You see those icons such as low oil pressure or check engine. And commonly, it's not fully understood what these icons stand for. So it's always advised to go with text-based controllers as it is easier to read and understand. So some of the electrical protections that we can configure using DSE controllers are the emergency stop. So if someone pushed the emergency stop button on the genset, we can get a feedback on the controller itself. We can read overspeed and underspeed alarms or have protections that would shut down the genset in case those instances happen. Over and under frequency. And from our discussion related to alternators, now we know that speed and frequency are correlated. Overcurrent, earth fault protections, supported by some modules, not by all modules. Over-under voltage, over-under battery voltage, the reverse power, which typically might happen in synchronization scenarios, and loss of excitation, plus many others. But these are the typical protections that you'd see on a genset. Now, let's go into the DSE WebNet. Okay. So, to utilize the DSE WebNet service, we'll have to install a gateway which connects our genset controller or the DSE genset controller to the internet, to the World Wide Web, to the DSE service, and from that point to the end user. So, two gateways are available from DSE, the DSE890 and the DSE891. The main difference between both gateways is that the DSE891 only supports Ethernet connection. So you'll have to have a DSL connection with a modem on site near the genset that is connected to the internet, which you can link to your machine or genset. On the other hand, the 890 is more flexible. So you can have a 3G or a 4G data SIM inserted into this module, which directly connects your genset to the World Wide Web. Plus, there's a provision for a GPS connection. So basically, when we get a remote monitoring or a web monitoring inquiry, we do advise and we do go with the 890 Mark II gateway. In this slide, we can see an overview map of the gateways in action. So let's have a look here. Okay, so what we can see here are different generators spread across different sites over the globe. For example, site 1 is in Africa, connected to a genset. Site 2 is in Australia, Site 3 is in the UK, and Site 4 is in North America. So all over the globe, different gensets are spread around. We'd like to monitor all of these gensets using a single platform on a single screen. So here comes the DSE WebNet service. These generators are connected to the DSE gateway, which, as we mentioned, could be the DSE 890 or the DSE 891. Now, what kind of connection does these gateways support? As you can see here, I'm not sure if it's clear for you, but we can connect the genset controller with the gateway via USB, an RS232, or an RS485 Modbus connection, or even an Ethernet connection over Modbus TCP IP. Now, this gateway should be connected to the internet, the World Wide Web. Okay, so in case of 891, we'll connect this to a modem via an Ethernet cable. In case of 890, we can simply have a data SIM placed into the gateway, which connects it to the service provider and thus the internet. This connection over here makes it possible to connect all these controllers to the DeepSea electronics server, and then the user could have access to all his machinery on site. So we can read all parameters real time, and we can even control these units. So when DSE WebNet was designed and developed, several things were put in mind. First of all, maximizing system uptime. Okay, so one of the purposes of using DSE WebNet is maximizing system uptime. How is this possible? We'll see how it's possible in the upcoming slide, but just briefly, DSE WebNet can alert you when maintenance works should happen. It can alert you if any fault happened, when the service works are required, so you can plan all of these ahead of time and not fall into trouble. For example, you can get a warning if your fuel level is low, so you wouldn't face the situation where you're out of fuel and your system is down. So maximizing system uptime is just like the opposite of minimizing system downtime. You don't want to go into these kind of conditions. So DSE WebNet would help you avoid these kind of situations. Next is optimization of fleet revenues. Now these two, maximizing system uptime and optimizing fleet revenues, are correlated, are linked by nature. So whenever you're maximizing system uptime, you're making more profit, less loss, definitely. It would also help us effectively monitor maintenance and servicing schedules, as I've mentioned earlier. You'll also have the facility to control your equipment remotely 24 hours a day. So this is even helpful in standby applications. When you have your genset in idle mode and you'd like to make periodic testing, let's say, every month or every week. So rather than relying on a scheduler, you can be in full control of when will these gensets start, when will they stop. You can read all parameters remotely from the comfort of your home. So let's go into more depth and discuss key features of DSE WebNet. So DSE WebNet allows for single user or organizational accounts. And this is very important because users can access a single account or an organizational account with different users, utilizing flexible permissions with customized branding. So you'd allow to set up different user permissions or user privileges, as we call them. So you wouldn't worry about some people accessing certain pages or controls with no authorization. You can actually configure that and make sure that everyone is only capable of seeing and controlling what he's supposed to be. Customized branding is very interesting. Basically, you can change the DSE WebNet startup page. For example, if you are running a rental company and you want your end user to make use of this DSE WebNet service, he can log into your DSE WebNet and he wouldn't see anything related to DSE. He would see your logo on that page, your brand name, your company name. Okay, so you can customize it based on your personal needs. Another very interesting feature is called geofencing and asset tracking. Basically, what we do with geofencing is that we create a virtual geographic boundary around the genset. Okay, and using GPS to notify users if the equipment is moved beyond it, and we can also monitor the equipment real time in order to assist recovery. So, for example, in case of theft, you can draw this boundary around the genset for the DSE WebNet to notify you or warn you at any point in time when this genset is moved away from this boundary or geofence. So you'd know that something is wrong. You'd know that your genset is moving away from its location. And as it moves, you can track it in real time, okay? Now, just a side note, in order to use this functionality, you'd have to have the GPS feature activated. So you'll have to be using the DSE890 gateway, along with a GPS antenna. Not only in theft, also in rental applications. For example, if your contract with your end user states that he shouldn't be using these gensets or machinery beyond a certain geographical limit, you can also utilize this function to track your generators. You can also have configurable reporting, which means automatically sending reports via email or SMS to maximum of 25 users, providing important information for efficient fleet management, which maximizes system uptime and keeps effective maintenance schedule. So back to the same idea of maximizing uptime and increasing profits. These reports are user configured, so you can configure whatever kind of data or parameters you'd like to see on a monthly basis, on a weekly basis. These reports are issued automatically and sent to you via email or SMS. Now, just another point related to the same issue, if you want to use the SMS feature, you'll have to have a SIM card in your gateway recharged with airtime, not only a data plan. Okay, so for the gateway to be able to send an SMS notification, the SIM card has to be recharged with airtime. So definitely, we're talking about the 890, not the 891. You can also do maintenance scheduling and logging. This is a very interesting feature where you can plan and customize essential maintenance of equipment operating schedule and keep logs of previous maintenance work. So rather than manually tracking, especially if you have a large fleet of machinery, you can set these maintenance schedules, preventive maintenance schedules. Let's say, for example, you want to change your oil filter, air filter, belts, for example, every 250 hours of operation. So you can schedule that and you will automatically receive notification when your service is due. You wouldn't have to go manually and check how much running hours you've put on that machine and then decide whether you will be servicing or not. So this is an automatic operation which will make your life much, much easier. You can also have configurable user interfaces. So you can manipulate or change the user interface to meet your needs. So you can create the user interfaces using configurable widgets and templates to allow users to view key equipment and site data quickly and easily. And I've personally used this, and the possibilities are endless. Really, it's really nice. I don't know if the picture is clear here, but you can see that you can place different widgets. You can read various parameters. You can also put the necessary buttons for your application. You can play around with the colors. There's graphs. It's really nice, and it makes it a more personal experience for the end user. So you'll be focusing, for example, you don't want to see hundreds of parameters. You just want to see whatever parameters you're concerned about. It's very easily done with the configurable user interface. We can also set event triggers. So another type of notifications via SMS or email when specific conditions occur, including active alarms, for example, low fuel levels and genset status. For example, you'd like to know when a certain event happens. That's why we call them event triggers. You will configure this on the DSE webnet. For example, you'd put, if the emergency button was pushed, I'd like to know. Okay, so that's the event trigger. Then you'll be receiving an SMS or an email based on the configuration, definitely. And this is really important because you don't have to be right next to the genset to know what's going on. You can be sitting at the comfort of your home and know everything that's going on. There's also user configurable access, and I've talked about this in when we were firstly discussing the key features. This allocates different user privileges, giving admin users the ability to provide full control or read-only access to prevent accidental system changes. Okay, so if you're running an organization and you have several users accessing the same account, you wouldn't have to worry about people going into different settings and changing things where they shouldn't have. So the DSE webnet works across any phone network. It's compatible with SIM cards from any network provider, allowing the 890 and the DSE 891 to be used around the world. So all you have to do is to get the 890, plug in a SIM with a data plan, and you're ready to go. To wrap up everything related to DSE webnet, there's an app for mobile or tablet. It's available on iOS and Android devices. The app can be linked to site pre-configured using a desktop connection to provide additional control and monitoring access. Myself, I have this DSE webnet app downloaded on my phone. It's very user-friendly. If you're utilizing the DSE webnet, I'd really advise you to download it and make full use of this service. Last but not least, I'd like to give you a brief overview on the Jubaili brothers and the DSE Electronics affiliation or business relationship. So what you see on this slide is a certificate from DSE to Jubaili brothers certifying that we are a recognized DSE Electronics OEM. And we've been dealing with DSE for more than 12 years, and we've purchased over 100,000 units of genset controllers from DSE. If someone asked me about the relationship between Jubaili brothers and DSE, I would say it's not just a relationship, it is a partnership. We do work on research and development in conjunction. We do support each other. We're also currently developing a hybrid control module for solar and generators to work in parallel. We'll give you more information on this module when the time comes. Probably my colleagues from the solar department will be giving more information on this. Thank you so much for listening. I think we're ready for Bedig's part of the presentation.
Okay.
So I'm gonna turn off my cam and audio and leave the floor for you.
Thank you very much.
Most welcome.
All right. Firstly, thank you for Jubaili bros, and thank you for Fayssal for the very nice introduction. And I don't want to speak a lot about our relationship with Jubaili, but just to let you know that many of the features inside the DSE controllers have been obtained from Jubaili's expertise. So many of the features and the functions that you see today were asked by Jubaili's technical team. Let's go forward with our presentation. So today it's just about products familiarization. What are the main DSE products? Well, firstly, DSE has 4 divisions. We got the genset division, the ATS, the power, and the control. Within the genset division, we have obviously the genset controllers, generator controllers, as well as AVRs, communication solutions. We'd also have ATS controllers within our ATS division. In power division, we do have chargers, static chargers or simple chargers, intelligent chargers, and the DSE control, where we have engine control units for engine-only applications such as pumps driven by engines, not alternators, and as well as mobile applications, PLCs, advanced PLCs. Right. My name is Bedig Boghossian. As Fayssal introduced me, I'm the technical support engineer of DSE Electronics. Those are my contact details. I'm based in Lebanon, and I mainly look after the Middle Eastern regions. So if you need our contact details, they are on the screen now. If you got any technical question related to the DSE controllers, you can always contact us to support@dseelectronics.com. We also have our website, dseelectronics.com, where you can register. By the way, I do strongly advise you to register on our website, where you can have product updates, what are the new features released, what are the new products, and so on. Also, if you need to access to the manuals, to our training materials from our website, you need to be registered. If I was going to talk about all the DSE products in details, I would need a full day. Maybe a full day won't be enough as well. But just to show you what are the DSE controllers, an overview on the products. So we got generator controllers, we got standalone genset controllers, synchronizing controllers, and expansion modules, because there are various models of DSE controllers. Some of them have less I/O, some other have more I/O with communication ports, and some of the other controllers support expansion modules. So in some cases, you need to add more I/O than you would need to use our expansion modules. We do also have AVRs, communication solutions, ATS controllers, which we will not speak about those modules today, battery chargers, and so on. What we will focus today are mainly 3 or 4 controllers. So let's start by the 61 MKIII controllers, 6110 or 6120. By MKIII, we mean this is the 3rd generation controller. We previously had the 6110 and 6120. They were on the Mark I variant, but today when you read Mark III, that means that they are the same controllers evolved, so they got more features, but used for the same application. So what you are seeing now is the 6110 and 6120 MKIII. They got full control buttons with generator push buttons, generator breaker and mains breaker, or generator breaker buttons, and full navigation buttons, the 5 keys over here. Previously, the older 61 did not have the full navigation buttons, but now we have this new controller, which is very nice for a standard daily used generator sets. And another thing is, you might ask, what is the difference between a 6110 and a 6120? The 10 term means it's a remote start variant. 20 means it's an AMF variant. So when you see a DSE series model ending by a 10, that means it's a remote start. So you need to apply a remote start signal, whereas the AMF variant can start automatically by sensing the mains. So that's the standard module 6110, 6120 Mark III. We will look at the basic features inside this controller on the next slides. The next modules are the 73 and the 74 Mark II. So from the front, both the 73 and the 74 look the same. And you notice that you have the breaker button controls, the breaker controls buttons. And the difference between the 73 and the 74 is that from the front, they look exactly the same, but from the back, there are slight differences. So on the 74, you have more terminals, such as the TCP port. You can see it over here. I don't know if you can see my cursor, my mouse. And then you have another connector for the USB for data logging. Both of these controllers support data logging, but the 73 doesn't have external memory, doesn't support the external memory, whereas the 74 supports the external memory, so it has a USB port for the data logging. Also, the 74 has an additional CAN port for a separate CAN link. So, for example, you have your electronic engine. So if you have your Perkins ECU, you need to connect the Perkins ECU to the DSE controller. You use the ECU port, which is a CAN port. By the way, you can connect on the same link other CAN devices such as sensors or AVRs, because nowadays you might have seen a lot of CAN devices where fuel level sensors, for example, they transmit CAN messages instead of analog signals. So you can link that on the CAN J1939 network of the DSE. But the 74 has an additional CAN port, so you can have a separate CAN network for those separate devices. It's just an option. We already saw the differences between the 10 and the 20, those models that end by 10 or 20. So when the genset module series end by a 10, that means it's a remote start module. And that means you need to configure a digital input to a remote start on load function, so that by activating that input, you start the generator when it is in auto mode. Whereas the 20 variants are the AMF controllers. That means they have an additional mains voltage sensing terminals. They can sense the mains voltage, and by detecting a low voltage on the mains, they can start the generator automatically. But you can disable this feature within the configuration of the AMF module by unticking, as you can see on the slide, on the image, you have the mains failure detection option. When you untick this, then the module will not start the genset automatically upon a mains failure, but instead you use a remote start on load input to start your generator. What are the main features inside the 6110 and 6120 MKIII? It has an internal PLC, so whatever feature or functionality that is not inbuilt inside the controller, you can customize that. You can make a simple program within the PLC logic of the controller to achieve what you need. It supports data logging with trigger points to monitor instruments variations. So for example, if you need to monitor the engine temperature, and you can configure the engine temperature item inside the data logging configuration section, and then the module will be data logging the engine temperature. And you might also be looking at the kilowatt level. So if you have a problem on the engine temperature, you know that the engine temperature rises because of overloading. Then you can configure other items associated with the engine temperature, such as kilowatt total, current, etc. And then after the trigger point happens, after a trigger point, you can read the data logging, and then you can compare, or you can view the data logging graphs. Why did the temperature rose on the engine? Well, you can look on the graphs, and on the same level, or at the same time, you can look at the kilowatt level. Then you can know that because of high kilowatt levels, the engine was rising, and you can show this to the operator or to your end customer. It supports all the expansion modules. It has 8 digital inputs, 8 digital outputs. It has 4 analog sensors, and 2 of the analog sensor inputs, the A and the D, are ratiometric. What do we mean by ratiometric? You know, nowadays, most of the sensors are resistive analog. But today in the market, we see a lot of voltage variable sensors or even current variable sensors. So if you have such sensors, then you can utilize it without the need of any expansion module. It also has a scheduler. It supports the DeepC intelligent battery chargers over its DSE net port. It supports J1939-75. This is a communication protocol to transmit all the genset instrumentation over the ECU CAN data link. So if you have an external CAN PLC, you can use that to receive all the CAN instruments, all the genset instrumentations via the CAN. Plus configurable CAN instrumentation. The configurable CAN instrumentation has been very useful today because of the CAN sensors. So if you have a CAN fuel level sensor or a fuel flow meter where you need to know the fuel consumption, then you can connect that over the CAN link and then configure the message ID and the data structure of the CAN instrument. Of course, if you needed more information, detailed information, it's found in our operators and software manuals. Plus, you have our support from DSE Electronics. Next, the 7310, 7320 Mark II. It's very similar to the 61 Mark III, but with additional features. And what are the additional features? It has more digital outputs. It has more analog inputs. So you have 6 analog sensor inputs. Again, it has 2 ratiometric inputs. It does support communication ports. So within your application, you have a BMS reading requirement. So the end customer wants to monitor the genset instrumentation via the Modbus. We support that over the RS-232 and RS-485. This controller, the 73 Mark II, doesn't have a TCP port. So if you need a TCP port, we are able to provide that on the 73 by adding another accessory, which we will look at on the next slide. It does also support the dual mutual standby over communication links. We will look at the dual mutual standby on the coming slides. does also support the CAN AVR. We're speaking about deep sea AVRs, or J1939 supporting AVRs, where we can control the voltage at some point and also read all the AVR instrumentations and show it on the display. It also supports remote displays, the 25 MKIII and the 8003 Mark II. The 74 Mark II is very similar to the 73, but with more additions. If you look at the points over here on the slide, you see that there is an additional data logging feature. Is it? Oh yeah, so it has the USB memory capability. You can data log onto an external USB memory, because the internal data logging memory is limited to 2.5 megabyte, I think. But with an external memory, you can extend that to up to 16 gigabyte GB. It has internal PLC, obviously, so it has all the same features as the 73, but then it has 4 ratiometric inputs. Again, it has 6 analog sensor inputs, but it has 4 ratiometric inputs for various sensors, such as current variable or voltage variable. Additional to the RS-232, RS-485, it has an Ethernet port. The Ethernet port serves for TCP communication, TCP Modbus, as well as SNMP. So one of the points here, you can see it supports SNMP communication. SNMP is not widely used, but it is sometimes required by IT institutions, banks, or other network, advanced network related associations or organizations where they want to read trap messages. They might be reading trap messages of other devices, and they also want to read from the genset controller. Then you can provide the 7420. So as you can see, the 74 Mark II is for special applications. Again, it supports the CAN AVR. It supports the remote displays. It also has the dual mutual standby feature. And what is the dual mutual standby? That's on the next slide. Okay, here on this slide, we are showing you some of the protections features which are not available inside the 61 MKIII. So for basic applications, it's very nice to use the 61 MKIII. That's a perfect solution. But when you come to require more features, more protection, such as negative phase sequence protection, which provides protection against unbalanced loads on the 3 phases, then that's not available inside the 61 MKIII. The earth fault protection is not available as well. Field use and efficiency is available via the electronic CAN, but not available for conventional engines. RS-485, RS-232, dual mutual standby, remote displays, close transition, engine icon displays for stage 5 tier engines, tier 4 engines, dummy load and load shedding controls. All of these features are not available inside the 61 MKIII. So whenever you need these features, you go to the 73 Mark II or 74 Mark II. By the way, some of the features can be applied using the internal PLC, but it will not provide the right functionality as required, whereas the 73 has them, it provides them nicely. We spoke about the dual mutual standby. Dual mutual standby means 2 generators ATS application. So if you got an ATS application between 2 generators, it's very common in the telecom sites, then you can use the 7310 Mark II. So the 7310 Mark II, they can communicate together via the RS-232 or RS-485 to communicate together and make the balancing between them. And within the dual mutual standby, you got different modes, such as engine hours. How do you want to make the balance? Is it based on engine hours, or is it based on time, or simply running engine time? All of these are configured within the 7310 or 7320. Within this SLD, you notice that you have a mains source. You can also apply 3-source ATS application using the 7320 MKIII. Because the 7320 is an AMF module, that means it can sense from the mains. So you can have a 3-source ATS application simply by using the 7320 Mark II controllers without the need of an ATS controller. And you can simply use 3 breakers for each of the sources. By the way, both the 73 and the 74 support the dual mutual standby. So this feature is available inside all the 73 Mark II and the 74 Mark II series. Remote displays. Sometimes it is required to have remote displays for local monitoring of your generator. We provide 2 types of solutions on the 73 and the 74. You can use the same 73 hardware. So you can bring a 73. Suppose that this is a 73 controller, and then simply by applying a firmware update using a special DFU file called 2510 MKIII or 2520 MKIII, and then the 7310 can be converted to a remote display. And then this 7310 can be used as a remote display for your 7310 MKIII or 7410 MKIII. So again, let me iterate this about the remote display. It is the same 7310 hardware that is converted to a 2510 MKIII. We call it 2510 MKIII. That is the remote display. After becoming a 2510 MKIII, it can support both the 7310 MKIII and the 7410 MKIII. So you can have a mirror controller on your generator. So you got your main controller on your generator, then you have another controller as a monitoring device that links via the RS-232 or RS-485. And you can have multiple 25 MKIIs connected to the same 73 or 74 modules. Plus, we do support the 8003 Mark II, which is a touchscreen remote display. It supports the 73 and the 74 MKII controllers. We got some expansion modules. As mentioned earlier, if you need more inputs, more outputs, the DSE controllers support multiple expansion modules. So you can have, let's say, up to 4 2130, which is a digital input or analog input expansion module connected to a single genset controller. Well, each of the series have a maximum limit of supporting expansion modules. Those are detailed in the operator's manual. Some of the controllers, such as the 73 Mark II, has 4 LEDs in the front. Don't know if you can see my camera. So this controller, for example, it's an 8610, by the way, but I'm just showing you as an example. It has 4 LEDs. These LEDs can serve to show indications. These are LED. They are LED indicators that can show you functions such as breaker status, is it open or closed, alarm status, communication link status, mains, etc. If you need more than 4, you can use the 2548. So that's the 2548, and you can add up to 10 annunciator modules, and each 2548 has 10 LEDs. Other expansion modules for communications. Now let's go to our synchronizing modules. We do have synchronizing controllers, and there are various synchronizing applications, such as synchronizing one generator to a single mains, or synchronizing multiple generators together, or maybe main synchronization between generators, or maybe a group of generators. So all different sorts of synchronizing applications require a selective module. So you select the module according to the application. The most common synchronizing controllers are, the controller is the 8610 MKIII. The 8610 MKIII is a generator synchronizing controller. So if you have a multiple generator synchronizing application, you use the 8610 MKIII, where devices need to communicate together via the MSC. If you got a main source, then you use the 8660. If you got one generator to one mains paralleling application, you simply use the 8620. So again, if you look at the model number, the ending 2 digits stand for the application somehow. We saw earlier that the 20 stand for the AMF variant. So that's for the single generator with a single mains application. But for generators, you use the 10, which is the 8610. But the 8660 is for main synchronization. Then we got a bus tiebreaker controller. It's the 8680. We have a two-part solution for the 8660 because sometimes within the mains synchronizing application, you got your mains breaker in a certain location and your bus breaker in a different site. And then you need a communication device in order to control the breakers. That's the job of the 8661. We also got new controllers. It's a single unit, the 8920. It's a new controller. It has a 7-inch color screen display with graphical representation, and the 8920 can be converted to an 8910. So you'd know the 8920 by the last 2 digits that it's an AMF variant, but it can be converted to an 8910, and it will become a generator synchronizing controller. So that's an overview on our synchronizing controllers. By the way, the 8620 Mark II can also be converted to an 8610. A simple SLD diagram showing you a synchronizing application where you have your generators in parallel. So for generators, you need to use an 8610 or an 8910. Your main source need to have an 8660, where the 8660 controls the mains breaker and the bus breaker. But if you got only one main source, then you can avoid the bus breaker on the 8660. But for multiple mains source paralleling application, you need to have both the mains and the bus breakers. For bus tie breaker application, if you have bus segments, you need to use the 8680 for the bus tie control. Let's have a quick look on the features or functionalities of the 8610 Mark II. Well, it supports the data logging. It has an internal PLC. Now it does also support an advanced PLC with advanced PID control or custom functions, PLC functions, all can be drawn, as well as PLC communication through the modules within the PLC of the 8610 MKIII. So it's an advanced, the 8610 has an advanced PLC editor. It got 12 digital inputs, 12 digital outputs, 4 ratiometric analog inputs. All the analog inputs are ratiometric, as you can see. And I will jump a little bit. It has 2 MSC ports. The MSC stand for multi-set communication. It's for the synchronizing modules to communicate together because they need to transmit messages to each other or read messages. What is the bus kilowatt, or what is the percentage that each of the genset has to provide over the controller, over the bus, I'm sorry. So all those are handled by the MSC communication. And because it has an additional CAN port, so you can have a redundant MSC. It supports SNMP. It supports all the remote displays, plus the deep sea CAN AVRs to receive data and also to voltage control. That's the 8920, which we spoke about. It's a new controller. It has a 7-inch color display. So if you need, it's for special requirements where you need to have a large screen view. And from the back, it's very similar to the 8610. So the terminals are the same, but with different positions. But it has all the terminals that the standard 8610 MKIII has, except for the RS-232. So the 8920 does not have an RS-232. And that's the 8620. We saw earlier that the 8620 can be converted to an 8610. So you can use an 8620 for main spiraling application, and then if in the future you need to add other generators, there's no need to replace the 8620. The same 8620 can be converted to an 8610 to be used in a multiple generator synchronizing application. This is why it has an MSC port. So our generator controllers are able, with the 8620, is able to be converted from the AMF variant to multi-set multiple generator synchronizing application. Here on the slide, we're showing that you can use both MSCs on the 8610. So you suppose you have your MSC1 connected, and then you can enable the MSC2. It's called redundant MSC. Then you can connect it. So suppose you have a failure on MSC1 because of a cable damage or whatever reason within the site, then the controller can jump to the MSC2. Here in this slide, I'm showing you an image from the configuration for the load control mode. The default mode is the kilowatt share, but we can also add the droop mode. What we mean by a droop kilowatt share is that the DSE controller will be capable to load share without the need of the MSC. So you got your MSC1 and MSC2. If MSC1 fails, it jumps to MSC2. But now suppose that both MSC communication links fail, then we can use the droop load share mode. With the droop load share mode, we can have an infinite number of generators synchronized together because it follows a certain curve drawn in the configuration. And according to the frequency level, it can provide a certain kilowatt output. Or according to the voltage level, it can provide a certain kVAR power level. It's like a code, if you want, following a code on the frequency level or on the voltage level. The droop load share mode is also useful for other purposes, such as to parallel the DSE controller with non-DSE control generators, or maybe inverters. Suppose that you need to synchronize the generator to an inverter, let's say, and then we cannot communicate with the inverter because they use totally different protocols. And then we can use the droop load share mode in order to export frequency or export kilowatt, export kVAR according to the frequency and voltage levels. By the way, all these details are found inside the operators and software manuals of these products. And lastly, about the synchronizing controllers, all different variants are all compatible together. All DSE controllers are designed and manufactured in the UK under one roof, so there's no other location for DSE. They are all manufactured and produced within the same location, within the same factory. And they are all tested and they conform to various environmental standards such as electromagnetic, electrical safety, temperature, vibration, humidity, and shock. All of these standards are to conform with the CE or the UL. The DSE GenSat controllers also comply with the IEEE C37.2. I'm sure you have came across many of protection functions such as ANSI devices. And what are those devices? There are numbers for those functions which refer to specific protections such as earth fault protection, sync check, under voltage alarms. If you look at the different ANSI functions, if you look at the different numbers, they all refer to specific alarms or specific protections, and the DSE generator controllers comply with all of those protections. You can look at the operator's manual for more details. We also conform with the UL standard. The UL is a requirement in the US and Canada. Remote communication solutions. We do have the 8004, the 8003. So that's an overview. But yeah, underneath on the bottom you can see what Fayssal has already covered: the gateways and the DSE webnet. On the top you have remote displays. So if you need remote monitoring solution, that's the DSE webnet. That means you're in a different location and you need to monitor your generators, use the DSE webnet solution. But if you need a local monitoring solution, you use one of these solutions. The 855 and the 857 are converters from USB to TCP or RS485. For example, if you're using the 61 MKIII module, because the 61 MKIII does not have an RS485 port and no TCP port, and suppose that after a certain time, the end customer asks you to have a BMS solution, and then you need to have an RS485 or TCP port on your GenSat controller. Well, previously you had to replace the controller with a communication supporting controller, but nowadays you no longer need to do that. You simply need to add an accessory, which is the 855 or 857, to provide the communication port. I did not mention about the SNMP. We also have a special gateway for the SNMP communication that's called the 892. We earlier saw that the 74 MKIII and the 86 MKIII supports the SNMP communication internally, but some of the devices do not support the SNMP. In that case, you need to use the 892. That's the 8004. It's a 10-inch display. If you take it diagonally, it has a 10-inch display with a color and touch screen graphical representation. It supports up to 20 modules. It communicates with all 8000 series modules. Well, then we have the 8003 Mark II. So why do we need a remote display? Suppose that you have 10 generators within a site. We're speaking about synchronizing generators, and the operator needs to have a look on all the generators via a single display. Then he can use the 8003 Mark II or the 8004 instead of jumping from one generator to the other. He can simply navigate through this one remote display to view all the alarms, event logs of all the controllers inside the system. The 8003 has a 7-inch color display. It's a nice graphical display. And again, it supports all the 8000 series modules plus the 73 and the 74 series modules. The DSE SCADA suite is a free PC software. It's called 8005. That's the part number, but it's a free software. It's part of the DSE configuration suite. So when you download the PC software, part of the installation is called SCADA suite. If you tick that button, and then you will have this SCADA suite on your laptop where you can monitor up to 40 generator controllers over your PC. And the supported modules are all listed beneath. If you can see the 73, 74, and the 8000 series. Regarding the 855, the 855 is a USB to TCP converter for the modules which do not have a TCP port. But the 855 has an internal web server for friendly, simple SCADA interface. So by just opening an internet browser, you can type in the IP address of the 855, and then you can have an interface to view all the instruments and control buttons, as you can see here. But there are some limitations. It doesn't show all the alarms. Also, it doesn't show the events. The last topic is about the chargers. We have a wide range of battery chargers. What you can see on this slide are the standard chargers. We do have 12 volt and 24 volt chargers. The most common chargers are the 5 amp variants. So let's start from the 9150. It's a small charger. It's a 12 volt, 3 amp output. Then if you need to have a 5 amp, the standard, you use either the 9130, 9255, or the 9700 series. And what are the differences? For standard applications, 12 or 24 volt, 5 amp output, you can use these type of chargers which look like this. Whereas the 9700 series are exactly the same as the 9130 and the 9255, but the only difference is that it mounts vertically. So if within your panel you need to gain some space, you use the vertical mounted charger. But bear in mind that the vertical mounted charger has a larger height. So when if the depth of your panel is short, is not too much, then you need to be careful that the device mounted on the door does not touch the charger. Lastly, the 9155, it's a 2 amp at 30 volt. So for 30 volt applications, such as switchgear applications, in some panel applications, you might need a DC power supply for your 30 volt breakers. Then you use the 9155. Those are standard chargers. By the way, all DSE chargers can be fitted directly onto the generator without worrying about the cranking or protection on the batteries, because the DSE chargers have internal protections which are short circuit protection, overcurrent protection. With the overcurrent protection, you make sure that or you don't worry about the cranking, because when you start the engine, you know that the starter draws a lot of current from the battery, and then it could cause an overcurrent on the charger, or could cause a voltage drop across the batteries. But the charger, the DSE charger, detects that and it switches off the output to protect itself. It also has reverse polarity protection. So if by mistake you connect the terminals oppositely, positive to negative instead of positive to positive, for example, then you don't need to worry, because it's all protected. You won't cause no harm either to the charger or to the battery. And lastly, the temperature compensation and the D-rate output. All the DSE chargers, even the standard chargers, have temperature sensors on their board. When they detect high temperature, we're speaking about the ambient temperature. When the ambient temperature rises, then the DSE charger will detect that, and it will start reducing its output current, so it protects its own PCB. Lastly, intelligent chargers. We also got a range of intelligent chargers, but we will not speak about, I will not mention all the intelligent chargers. I will just mention about the standard intelligent charger, which is the 9470 MKIII. it can be configured to suit 12-volt applications or 24-volt applications, and its output current limit can be reduced down to 1 amp. Plus, you can select the type of the battery that you have connected. So as you can see on this image, it's a screenshot taken from the 9470's configuration file. It shows the selection of all the battery types. So depending on the battery type that you're using, you select the battery type so you make sure that you keep the battery lifetime longer or maximum. The advantage of the intelligent battery charger is that it charges at different stages, whereas the standard chargers, they just have a continuous output and with a simple float stage. Whenever the battery is fully charged, then it can jump to a float stage. But with the intelligent chargers, it's smarter. It can detect the voltage level of the battery, and then it can start softly without damaging the battery to keep the lifetime of the battery longer. And there are 5 stages. We also support lithium batteries in case you don't have, in case you're using a battery type which is not listed within the inbuilt configuration over here, then you can choose custom, and then you can make up the profile. We also, this battery charger also has an RS-485 port, which can be configured as a DSE net, so that you can monitor all the charger instrumentations on your genset controller. Or you can use the 2541. This is the 2541, which uses RS-485 to link to the intelligent charger, and then you can view all the instruments. On the DSE website, we have a support section. So you can see on the top of the website page over here, the second tab is the support. If you go to the support, there you can view all the products, or you can select to go through the different pages of the products. You also have access to the PC software. We have 3 PC softwares. Mainly it's the DSE configuration suite that you use. We also have other software products. And within this page, you also have the frequently asked questions. If you scroll at the bottom of the page, you have a section called Frequently Asked Questions, FAQ, where you can see what are the common questions and you can benefit from those answers. And that's everything. Thank you. We're done now with our presentation. So Fayssal, please go ahead.
Thank you, Bedig, for your presentation. It was very comprehensive and very informative. Thank you so much. I think we can jump into answering the questions that were posted during our presentations. So Daisy, if you can publish those questions, please. Okay, so first question from Qadir: is engine governor and ECU, ECM the same thing? The shortest answer is yes, they are the same thing. Not governor, just the ECU, ECM. 890 and 891 both supports the GPS antenna. No, it's just the 890 that supports the GPS antenna. A question from Nihar: please also explain how to import and export modified backup file. Can you answer that question, Bedig?
Yeah, yes. Within the configuration, within the PC software, we got a section within the file. Can I share my screen?
Yes, of course.
Share screen. Okay, I'm sure you can see the screen. This is the PC software. By the way, I did not speak about the PC software, so just an overview on the PC software. It got the connection type. When you connect the DSE module, it will show it over here. USB ID, what is the model type, the version. You got the open and the read file. And then you have other tabs over here, which the icons are self-explanatory, I think. Within the file, you got your import and export. No, it's in the tools. The backup module and the restore module is within the tools. So I don't know what you mean exactly by backup a configuration file. You might be looking at the configuration. Let me open a different PC software. So suppose that you have this configuration file which you have open in front of you. The PC software has two sections. It has the main configuration section, which is the left top part, and you got your SCADA configuration, which are for the calibration and instruments monitoring.
Bedig,
Yeah.
I think we've got a technical problem. We can't see your screen actually.
Ah, sorry. Okay. Is it okay now? Are you able to see the 86.2? Yeah?
Not yet.
Okay. Sorry, my mistake. I think
No worries.
now it'll be fine.
Yeah, now we can see the configuration suite.
All right. So, yeah, I was saying that the PC software contains two parts. There is the main configuration section, which is the left top part, as you can see over here, and you have the bottom part, which is the SCADA part. When you make a standard saving, when you save your configuration, it will only save the upper part. But what about the lower part within the SCADA? The SCADA is to configure some calibration items such as the governor interface, transducers for analog sensors, current inputs, current CTs, etc. But all of these interfaces, so I'm within my SCADA section now. If I go to my generator, governor, and AVR interface, notice here you have the calibration interfaces SW1, SW2. But when you make a standard saving for your configuration, it will not save these settings. To save these settings, you use the backup. So the backup is done from the tools. You go to your tools menu, and then you make a backup module, as you can see from here. So that's the short answer. That's where you do your backup. Once you make a backup, it will ask you where do you need to save the backup file. And then once you save it, you cannot open it on the PC software. You can only write the backup module into another similar controller with the same version.
Thank you. That was very clear. So next question. Ahmed Jazini is asking, if it is mandatory for the 891 to be connected through Ethernet cable, what is the benefit of installing SIM card for it? Actually, Ahmed, for the 891, we cannot install a SIM card. It's an Ethernet-only gateway. The SIM card is installed in the 890. So any functionality related to SMS notifications or GPS tracking, you'll have to go with the 890.
Mm-hmm.
What will be the additional CAN network usage for? Ahmad Mansour is asking.
Mm-hmm. On the 74, it can be used for CAN devices such as CAN sensors, fuel flow meters that can transmit the fuel consumption, for example. But on the synchronizing modules, it is used for MSC, redundant MSC, to back up the load share communication.
Clear.
Yeah.
Next question for Tawana is asking, for DeepSea controller with grid sensing, are the units equipped with surge protection adequate for grid conditions? Well, Tawana, you can configure these controllers because you see any under voltage or frequency, over voltage or over frequency can be configured within the DeepSea module. So you can configure the DeepSea module to disconnect or switch based on these thresholds that you set. Definitely bearing in mind a certain time delay.
Can I make a few comments? Oh, sorry.
Yes, of course, for sure.
About the surge protection. The surge protection has to be a separate device. It cannot be within the genset controller because they are totally different equipment. And regarding grid protection, our synchronizing controllers provide mains decoupling protections for rock-off vector shift. That's all.
So Tawana is asking, for a typical telecom site, what features on the DeepSea controllers can I use assist with fuel use optimization for hybrid site with grid battery and DG? Tawana, these are typically related to the fuel safe controller itself. Okay, so soon a fuel safe controller will be released into the market, and our guys from the solar department can give you more information on this. For say a telecom site, can I use the DeepSea controller for other remote monitoring functions not specific to the DG, such as equipment cabinet, door, open, etc.? The way I would do this is I place a limit switch on the cabinet door and connect it to one of the digital inputs on my controller. So in certain these kind of applications, you have to play around things. It's not as straightforward, but definitely there is a solution. Tawana is also asking, are DeepSea controllers repairable in the event that one becomes faulty? All DeepSea controllers are covered under warranty. I leave the floor for Bedig to give more information on this.
Yeah, it depends from the nature of the damage. So there are some damages that could be repaired. If it was a component failure or a single component, individual component failures, damages, then that's okay, they can be repaired. But if the PCB was affected, such as the track on the PCB were affected, then the repairs won't be economical anymore. You need to replace in that case.
Yeah. One of the main challenges I am faced with on DGs is their failure to start when required because of a fault genset battery. Is there a way the DeepSea controller can be used to sense the DG battery voltage level and automatically run just to ensure its battery is occasionally charged and does not become flat? I see that, again, this question is posted by Tawana. I see that this is a standby application, and in such applications, we'd recommend using a battery charger. So a battery charger, a static battery charger, which is connected to the mains grid, would ensure that your battery is always fully charged and ready to start up your genset whenever required. If you cannot do that, if you cannot connect your genset to mains, and you're not always utilizing your genset, I think you can configure an event trigger via the PLC. So you can read your battery voltage, and once it reaches a certain voltage level, you can trigger a warning or an alarm.
Yeah.
Next question. Tawana is asking, can easily replace my power wizards with DeepSea controllers? I'm gonna let Bedig answer this question.
It's easy if you know the wiring diagrams. All you need to do is just take off the wiring, the connectors, and then you need to have the wiring diagram of the previous controller and the new controller. obviously the connectors, the locations of the connectors won't be on the same place. So it might need re-engineering in terms of panel cutout or maybe wirings. Obviously, it's not a straightforward job. No.
Yeah. Muhammad Qadir is asking, will the 6120 automatically turn off the engine when the grid gets live back? Yes, it would after running the cooldown timer. Qadir is again asking, is the CAN communication with open interface protocol and data can be read through a BMS over CAN protocol? I believe this would be related to the BMS brand or system that is being utilized. Bedig, any ideas?
Yes, when they speak about the CAN communication from the DSE controller, it should be the J1939-75 protocol or configurable CAN, custom CAN. It's a 29-bit message ID protocol, which we call it CAN2B. And it all depends, as Fayssal mentioned, it all depends from your CAN master device. How does it exactly communicate? Is it 29-bit or 11-bit? The answer is yes, you can read from the genset controllers via the CAN, but that depends from the configuration.
Tawana is asking, on sites with high theft prevalence of, say, DG batteries and fuel, what features on the DSE controllers can I leverage on for remote alert? Well, again, with the use of event triggers, and for example, let's consider fuel. You'll have to have a fuel level sensor, okay? And you would know your engine's fuel consumption. So you can program a trigger, okay, or an event that triggers when the fuel consumption is extremely high, okay? So something fishy or something wrong is going on. It's not your typical engine fuel consumption. There might be a leakage or theft. In this case, you will get a notification. But definitely you need the proper sensor to do that. Okay, so it could be an ultrasonic sensor of fuel or a fuel level sensor. Then you can measure your consumption, and if it's abnormal, you'll get the warning or alarm. Same goes to battery. If you're constantly monitoring the battery voltage, if it suddenly drops down to 0, it means something is wrong. Okay. So you can program event triggers for this kind of situation. What is the module used for BMS or SCADA? Typically speaking, modules with Modbus connections, like the 7.3 or the 7.4. If you want to use the 6110, as Bedig mentioned in his presentation, you'll have to place in a protocol converter, USB to RS485 or USB to 232. Another question by Muhammad Sheikh. For DSE modules, what is the best way to make a test for genset protections? Do we have to configure DSE modules for different values? This is one way of doing it. You can reconfigure using the DSE configuration suite. You can vary your values to test the warning or shutdown protection. Because in some cases, it might be very difficult to actually simulate the situation. Can a DSE controller be connected to a solar hybrid system in a mine grid? Theoretically, yes. There shouldn't be any issues. But you need to make the proper configurations on both ends, the controller and the fuel safe controller or the hybrid controller? I believe this was the last question. I'd like to thank you all for attending this webinar. Bedig, thank you so much for being our co-host. Ladies and gentlemen, please, we'd really appreciate it if you can fill in this webinar survey, and you will be receiving an e-certificate of attendance once you complete this survey. Thank you so much for your time and for attending today's presentation.
Thank you very much, Fayssal. And thank you for Jubaili's team.
Thanks.